wireless lingo. Okay, so here's the thing. It's actually wireless terminology, but I like the term lingo. It's a little bit funner. But here's the thing. And by the way, welcome to the class. Okay, we're here. But there's a lot of terminology with wireless networks. Take you through the basics, through the history, and then we're going to dive into some of the newer stuff and have a lot of fun in the process, right? So here's the thing. The wireless has actually been around since the 1800s, okay? And this was not wireless as we know it today. It definitely wasn't this AP over here, even though this is an older model. No way it was done in the 1800s, right? So we're talking about just kind of the invention of RF, or the discovery, I should say, of how RF works through the air and, comes from one side and can be transmitted to the other. The first wireless data network that ever came about wasn't until the 1970s, so quite a bit of time in between the two, right? And this was Aloha Net, and this was from the University of Hawaii, I believe. So, and Hawaii. So anyway, the Aloha Net is actually Abraham Lincoln of Heterogeneous Network. Yeah, something like that. But anyway, it was in 1971 it launched the first wireless packet network. And so, wireless has actually been around since the 70s, right, as far as data travels and as far as data packets, right? And so it wasn't using the protocols we use today, but, it was here's how I can send something from A to B, receive it on the other side, and understand it, right? So anyway, then we had the launch of the 900 megahertz band in the 1980s, okay? And then we got the use of the ISM bands in the early 90s, and this is where things really kind of started happening, right? The early to mid 90s is where wireless kind of took off because you had these bands that were now licensed and unlicensed. Well, there was always the licensed bands, right? And that's kind of the thing. We'll talk more about that whenever we get to RF, but we use the ISM and unibands, which we'll talk all about. But before this, before the early 90s, there really wasn't any unlicensed bands. I mean, there really, you had to get, a license to use the RF in the air, right? And so, or I should say the RF, right? And so on a particular band, and that's why there wasn't too many standardized things out, right? And so whenever this happened, the IEEE, and the unlicensed bands came out, right? And so like the ISM, the industrial, scientific, and medical, so then we started getting somewhere, right? And so in 1997, 802.11, which is the foundation of the protocol we know today, was ratified by the IEEE. Okay. In 99, we had the 802.11a and b ratified. A and B were both ratified at the same time. One same month, same time. One was the 2.4 gigahertz, okay, and one was 5 gigahertz. Okay. So we'll talk about those. Then we had the 802.11g was ratified in 2003. Getting speeds of like 54 megs, okay? And then 2007, we got the 802.11 in draft, which is up to 600 megabytes. So, you could see in the last few years, since this new millennial, right, we've come quite a way. So 600 megabits, and now AC is officially ratified, hooray, in January, right, of 2013. And so AC was ratified, actually, I think this was 2014. Sorry about that. I think January 2014. It might have been at the tail end of 2013, but I think it was 2014. And now we've got speeds of over a gigabit second wirelessly. Think about that. That's pretty cool, right? So a lot's happened definitely since the late 90s, early 2000s, and now today. And they're even working on some multi-gig speeds, now is the next thing. But AC has really just came out. It's kind of the baby of the wireless world. And now that we've got gigabit wireless speeds, voice, video, media, storage, all those types of things, content media, everything is no longer a problem for wireless because we've got the bandwidth to support it. Now, of course, you not only need an AP that supports that protocol, you also need the client device as well that supports it, too. So you got to be able to send something, you got to be able to receive it, right? So anyway, This is just kind of an overview of the history of where kind of we've come from, and we'll talk much more about where we're at today. So, Adhoc Network. Our wireless LAN network's created by adapters only. So you might have done this before. You got a buddy over at your house and you're like, man, we really want to share, some files between each other, and for whatever reason we need to do this. Well, you can do this with client adapters only, create an Adhoc network so that if you both have a wireless adapter, you can create what it's called is an Adhoc network, right? And so you can share files with just you and your buddy. And so you can use Windows to do that and create a wireless profile and then all that kind of good stuff. Also, Adhoc networking is done not just for sharing files between each other, but sometimes, I do an Adhoc network to share files between my tablet and my computer. So it just depends, right? Infrastructure mode is AP functions as a bridge between the 802.3 wired media and 802.11 wireless media. And so that's infrastructure mode. And then there's also one other mode up here that I wanted to kind of, we'll talk about that. So, 802.3 obviously is the wired Ethernet side, and then 802.11 is the wireless media side. And so the other thing we have is a basic service set, which is the service that one AP provides, right? An extended service set is 2 or more cells working together. So this right here would be an extended service set. And the goal between this, if they're both working together, okay, in partnership, is that if you had a tablet computer, you could roam between them, right? So if you look at your wireless network adapter and you see all those wireless networks that are available, in Windows, Unix, whatever you're using, that's the SSID. That's a beacon that's saying, hey, we're here, there's wireless services here, and by the way, here's the speeds I work on, if I use security or not, here's what that is, and so that's what that's for. So SSIDs are extremely important, and all of these terminologies so far, this is the basic stuff, but it's stuff you need to know. So here we are at an AP, and this is like a 3500 series AP, and we'll talk all about the AP models and all the different benefits they have, but he's a pretty good AP, okay? And but here's the thing, what we want to know is is it an autonomous AP? Does he have enough intelligence to serve wireless LAN users, okay? So in an autonomous mode, the software on the AP, you configure all the settings on the AP himself. It's kind of where the buck stops here, right? So he's got the intelligence for the wireless LANs. He manages all the wireless traffic, and then he also has the intelligence to do the distribution of that wireless traffic onto the wired network. So if this is a switch, okay, we'll just say switch 1, he could handle all the wireless traffic coming to him and then distribute that to the network all on his own. Now, there's another mode that these guys typically operate in too, which is called lightweight mode. And in lightweight mode, you've got the same scenario, but instead of having all of the intelligence on his own, you've got this guy over here that's called a WLC, okay, or Cisco Wireless LAN Controller, or Wireless LAN Controller. I guess we're talking Cisco, so it needs to be Cisco. But anyway, and in this mode, the Wireless LAN Controller says, Mr. AP, you do so much. I'm going to take away. I'm going to take care of distributing the wireless traffic to the network. So I'm going to take off the distribution load on you, and I'm also going to take care of setting up our WLANs, okay? And I'm also going to create the security policies, okay? And so all I need you to do is take care of the client association, send out what I tell you, radiate that frequency into the air, operate, in partnership with me, and then you handle the real-time stuff and I'll take care of the rest. And so that's called lightweight mode. And typically those wireless LAN controllers have many, many, many APs that they're supporting, right? Not just one. They're typically doing however many the building needs, right? But centralized management at that point. And we'll talk all about this guy a little bit later. But the important thing is that autonomous, he's operating all on his own, right? More on autonomous too later. So here's an example of this wireless LAN controller, and this is a 5508. And this guy is used to configure, manage, control many APs from a centralized appliance. And they also provide distribution of the wireless LAN data into the data LAN. So what happens here is this guy is connected to your switch. There we go. So he's going to connect into your switch, and then of course these APs are going to be connected into the switch as well. And then he's going to manage the APs just like we talked about. So I create all my configurations and settings and all that kind of stuff and set up my SSID and my LANs and everything, my wireless traffic. And then I also take care of sending that traffic out to the wired network. And so it depends on your particular type of deployment, because there's only so many APs that a single WILSI can manage, right? Now that we're talking about the speeds we're talking about, okay, with wireless LAN technologies of 300 and 600 megs per AP, and then also AC coming out now with gigabit speeds per AP, it's a different story. So that's why I also said this class is 2.5, because we're going to talk about how we take care of that additional bandwidth as well, which is, I guarantee, is going to be on the next CCNA. But anyway, and it's established by 2 or more client adapters, but you're limited number of devices because of this CCNA CA. And what that stands for is the Carrier Sense Multiple Access with Collision Avoidance. Now you're familiar with the CCNA CD from our Ethernet side, and so we're going to talk all about that process in a moment. I don't want to spoil the fun, but basically, you know, there's, with our wired network, okay, if these guys were connected to a there and listen for traffic, okay, and if they hear none, they can transmit and all that kind of stuff. But it's a little bit more methodical with wireless, right? Because it just is. I don't even want to step there right now because I just don't want to take us there with this introduction. So Adhoc networks are two client adapters basically creating a network for just themselves. They're not connecting back to an AP. They're not connecting, you know, back to a controller of any kind. They're just 2 machines connecting themselves, and it could be several devices, but again, it is limited instead of collision detection. So that's what the CA is there, is collision avoidance. We'll talk more about that in a moment. So back to our wireless LAN technologies. We've got a little chart here. I grabbed this from Mr. Google to show you the different technologies that are out, and there's many more than this, but Wi-Fi fits right in here in the range though, right? And this is meters. Okay, so, and you can see the speed is just going up and up, and now Wi-Fi is actually, you know, up here now as well. So, and you can see like the GSM and 3G and WiMAX, they have a much further range than the 802.11 does, and Bluetooth and Zigbee. But notice right here, all of these guys that are kind of sharing this same range of 300 feet, right? And then we've got NFC over there. But anyway, we'll talk more about that and what that means here in a little bit. So we've got this concept. In Ethernet, right, in our CCNT, we talked about a concept of a wireless LAN, and that's really where things started, was on the LAN side. Well, in wireless, we get to introduce a PAN. That's right, PAN. And that's personal area network. Coverage is a few feet, and the primary technology is Bluetooth, okay, 2.4 gigahertz. And Bluetooth standards, of course, continue to evolve. I was in my rental car, even my rental car nowadays has Bluetooth where it can hook into my cell phone, and I can call one without, you know, having to pick up my phone and all that, and so, and also listen to music. So Bluetooth has become a long way, and we're going to talk all about the Bluetooth technology in a little bit. This is still just an overview. Wireless LANs utilize the 2.4 gigahertz and 5 gigahertz spectrum. You know, this is also called the ISM band, which we'll talk about, and this is called the uniband. Okay, and support for multiple users, could be hundreds or thousands. There's more power than in a PAN, of course, but you have to adhere to regulatory standards, which we'll talk about that in detail as well. See, this is all the kind of foundational stuff I was saying we got to cover. Typical coverage, single cell could be 300 feet. Multiple cells could be extremely scalable across campuses, cities, all that kind of stuff. So you've got a concept of a wireless MAN. And it's not an actual guy, right? It's a wireless metropolitan area network. And so in this example, we've got like some cellular going out to end users, and then also we've got some like maybe microwave technologies, things like that. And nowadays as well, you may also have 802.11 floating around out here as well. Okay, because citywide metropolitan area networks for wireless has become really the norm, okay, in a lot of cities. So used within the licensed bands, and FCC has restricted areas we'll talk about that you can't go across restricted areas like airports and trade zones and all that kind of stuff, but we'll talk about that. And so wireless MAN technology usually comply with the 802.16 working groups. We'll talk about what working groups are a little bit later, and the range is a city or metro area. Okay, and also we might have some WiMAX stuff here as well. So we'll talk about what all those are in a little bit. And then we have wireless WANs, which are large coverage areas, and its services typically leased subscribed from a carrier. Cost is based on utilization. This isn't like our wireless LAN. Well, it is like our wired LAN, right? It's just the wireless version of it, and so you know, can scale across a large geographical distance, and that's what we're talking about. Wireless is a little bit different because the range on typical wireless is not what the range is on, let's say, fiber. Okay, but you could still get 20 miles on you know, wireless technologies. You could do over that depending on the speed. Which we'll talk about a little bit later. And then also wireless WAN, one thing I did not mention really in this slide was satellite. Satellite is a form of wireless WAN communication as well. Okay, and so a lot of times, this is actually what you see a lot in cities now. This is the 1500 series AP that's used for connecting citywide wireless mesh networks. So anyway, that's kind of the overview about the areas, and then right whenever we come back, we'll be talking about different modes to operate in, different wireless modes. I'll see you in a moment.
Start with new learning now.